Today's lesson is over section 10.7c. Here we'll be talking about quadratic factors that are distinct in the denominator. So first we want a factor, so in this case we will be able to take out the x. That gets us x times x squared plus 4. Now because you have a quadratic factor, that numerator for that one will be a little different. So I have the a over the x like I normally do, but here because it's squared, you're going to have a linear numerator in the top. So I will have two variables that I don't know in the numerator of b, x plus c, because it always has to be one less. That's why it's just a number on top of like a linear factor like x. So it's the same kind of principle. But then from there, the process is exactly the same. So I'm able to multiply both sides by the common denominator and then get those canceled out and then multiply my stuff through to get the following equation. And then I want to group my stuff like I've been doing. So I put the x squareds together, put the x's in a group, and I put the single constants together as a group. And then from there I can factor out what I can. So I'll factor out the x's and the x. Now here on the left side I actually do have an x squared term, an x term, and a constant term. So everything will match up. So I'll have three different equations. So a plus b equals 2. I already know what c is, and it'll be easy to find a. So I'll divide both sides by 4, get a equals 1, and then plug that in to find my b, which will end up being 1 as well. So now when I plug this in, I'm going to have a linear term above the x squared plus 4, which is a little different, but finding it is really not any different than when we were doing the other two types. Okay, let's do another example. Okay, so here, now with this denominator, I really do have to factor out a lot. So because it's 4 terms, I'm going to group. So the first two, I can take out an x squared. The second two, there's nothing really, so I can always take out the 1. So then I can factor it out to be x plus 2 times x squared plus 1. So I have an x squared plus 1, which is a quadratic factor. So it will get its own factor of bx plus c on the top. And then from there, the process is the same. So multiply both sides by the common denominator. Now because you have two binomials in the second one, I'll have to multiply bx plus c times x plus 2 to get the following multiplication out. And then I group, just like I've been doing. And then I can factor out the x squared out of the first one, the x's out of the second, and then leave my constants alone. So in this case, I'll also have 3 equations that I can use to solve. So a plus b will equal 1, 2b plus c will equal -3, and a plus 2c will equal 1. So from here, I chose to deal with the first equation and solve for the letter b. And then I was able to take that and substitute it into the second equation. So I can have 2 equations with a and c together. And then I can use elimination in those to help me figure out one of them. So in this case, I took my third equation, I multiplied it by 2 so that I could cancel out the a's. And for this example, c actually becomes a fraction of -3/5. So we're going to have another case where your numerators are fractions, making your fractions complex. So then we'll have to multiply by the reciprocal to make them not at the end. So after finding a, I'm going to multiply both sides by -1/2 because of the fraction on the other side. That'll make it easier instead of having to divide. It gets me 11/5. And then I can find what b is, which will be -6/5 once I plug it in. So now when I put these in, I'm going to have two terms in the second one that have a fraction. So it'll be -6/5 x minus 3/5. Now because they're both the same denominator, it's almost like I'm saying -6x minus 3 over 5. And I can actually factor out that -1 and put it out front, so I can say minus to the entire fraction. So you don't have to. You can keep it plus and then -6x minus 3 in the top, but I chose to pull it out front. Okay, thanks for watching.